The largest assignment you're going to get in your CellNav class is going to be called a day's work. It's probably the last portion of your major CellNav project. And it's useful because it really brings together all of the different skills we've been taught. It doesn't necessarily have an amplitude, but it's got star time calculations, it's got fixes, running fixes, compass corrections, LAN, everything. So that's why it's so critical to know how to do. It's also just a very long and extensive process because you're doing what would be the full work of CellNav over the course of a single day on a voyage. I was not able to find like a full copy of one. Instead, after like scrounging through notes and looking at texts from friends, I was able to find half of a CellNav project from a few years ago. So this is only the morning portion. It goes from morning start time all the way to LAN. But just to really quickly run through, it sets you in a DR position at some time around 4 in the morning, placing you on a certain track. And I think we're supposed to be in the Pacific here, sailing across the plotting sheet. And then over the course of the day, it has you calculate star time. Then at star time, you get a 3-star fix. You have to work that out. Then you do perform an azimuth sometime later into the morning. You get 2 sun lines over the course of the morning. And then you you calculate the time of LAN, and then take a sight at LAN and advance your 2 sun lines to get a running fix at the time of LAN. From there, it would go on to 2 afternoon sun lines, an afternoon compass correction, and then evening star time and evening stars themselves. So that would be the full project. But I didn't have that. We only have the first half. And because they're redundant, I think this will be good enough to show you in an applied setting how you would combine all of these concepts together. So this is going to be a long series of videos. We're going to have, one for each of these steps here. But here, just we're breaking down the basics, and then we're going to set up the plotting sheet to begin all of this. To make this all feel a little more concrete, you can see our first piece of information we start with is on the 4th of November, 1981, because that's when SDCW is regulated to. Our 0400 DR position is 18 degrees, 7 minutes north, 162 degrees, 36 minutes east. We're headed on course 250 at a speed of 15 knots. So this is one of those problems where you're not going to want to start in the center of the page. You're going to want to start way off to the side. Because we're going 250, you're going to want to start to the right side of the page. That way we have this full room to work with. We're only doing half of the day's work, so we'll probably get to like around here by the end of it. But a full day's work will get you to the other side of the page, depending on the speed you're moving at. So to calibrate the plotting sheet, we have to start with just our latitude. We were in position, our DR position was 18 degrees, 7 minutes north. It's important to note that we're headed on a southwesterly course, so we'll probably reach around 17 degrees at some point. So I think we should set our central parallel here as 17 degrees. So we'll start somewhere up here at 18 and move down over the course of the day. We got 16 down here. Okay. So then we'll just mark our points here. 17 in each spot. Yeah. And set. Okay. Okay. And like I've said before, with a larger problem like this, we're going to need to extend these out and have more degrees of longitude available for us. There's 60 degrees. Marker point right there, or 60 minutes, sorry. And then we'll do the same on this side. This portion is tedious, but luckily, because it's a day's work and we're using everything over the course of the same day, instead of having to do this, 6 or 7 times, you only got to do it once and then it's valid for the rest of the project. Part of why actual CellNav is a bit more pleasant than the CellNav you'd be doing in class, because it's not constantly restarting from the top. You base everything off of the previous work. All right, and then our DR longitude was 162 degrees 36 minutes east. So, and we're headed down a westerly course. So I think if we set this as 162, and then we would get 162.36 somewhere around here, that would be a good point to set our starting location so we could sail that way. So we'll set this one as 162 degrees east. That would make this 163, and so on. Okay. Now we can put down our actual position. Or actually, before we do that, we have to set our longitude scale. Measure this distance here. Bring it down to longitude. It should land right under the 20. Go. This down, make sure it's nice and even. 17 degrees north. There's our longitude. Okay. So DR latitude 18 degrees 7 minutes north. We'll measure out 7 minutes. Mark it here. Just want to double check that. Oh. That was on the wrong. Marked it on the far side at 163 east, but that doesn't matter. You can still just come across from over there like that. And then we're doing 162 degrees 36 minutes. So we come down to our longitude scale. 30. And there's 6 right there. Mark that where that lands. Remember, you don't want to get confused in which direction is which. Even though it should be really easy, it's the simplest thing to get wrong. People screw it up a lot, especially when you're in the Pacific and everything is kind of flipped around in your head. There's our DR position at 0400. Now we got to set up our course of 250. So right there we got 250. Draw that across. We're going to need to extend that down because we'll be using most of the page. Label that 0400. All right, course 250 degrees true. Speed 15 knots. Okay. Now we actually have our plotting sheet prepared so that when we move on to these problems, we can actually find everything and plot it down and get our fixes.